Hello again, everyone, and welcome to episode number 1 of the Enterprise Linux Security Podcast. We started at episode number 0, and now this is the first episode, and we're going to talk about common vulnerabilities and exposures, or CVEs, which is an important topic to understand, especially for the first episode, something that I was going to pitch as a topic to Joao, but he beat me to it. So how are you doing today?
All good, Jay. I hope you're fine as well. CVEs is like this foundational topic that gets tossed around in the news every now and then, and some of those vulnerabilities even get some fancy names. But this underpins most of the security talks, and people, when they're talking about some problem or other, they're actually mentioning one vulnerability or another, and that gets a CVE assigned. And at TechScare, we basically deal with that every day. I don't want to pitch the services or anything, but this is basically part of the job that we do, is dealing with new CVEs and working on fixes for them and all that. So it's appropriate for this podcast of ours.
It's absolutely appropriate. I mean, you guys are on the front lines of this. I think it's very relevant to talk about it. And I think your experience is actually very worthwhile, because if you're paying attention to this, on the front lines, as all these vulnerabilities are discovered, and some of which are given names, I think that it's an important thing to draw from. And CVEs, like you mentioned, they're given a designation or a number. It'll start with like CVE hyphen and then some number. Yeah. And that helps people like Google or find more information about a vulnerability. So if you do a scan and the scanner says you are impacted by CVE number, whatever the number is, then you could look that up. You could read about it. What does it take to actually, for an outside attacker to take advantage of it, if an outside attacker can, what the scope actually is, what you might be able to do to fix it, or at least plug the hole until a patch comes.
Yeah, exactly.
Some of which are given fancy names, which we're going to get to that, because I think we definitely have to talk about these crazy names that some of these are given, or code names and such. And I'm sure a lot of listeners have heard of a few.
Just going back to that identifier thingy. So like you said, it's CV dash a number dash another number. The first number is the year that the CVE was requested. Anybody can request a CVE from one of the registries or one of the entities that give them out. Red Hat, for example, has a service that lets anybody request a CVE to be assigned for a problem they are discovering or working on or something like that. It's a unique number. But it's important to notice that the first number, it's the year, and it's the year that the CVE is assigned. It's not the year that it has to be public. A CVE could be disclosed next week with 2020 in that number, and it would still be relevant and it would still apply now, but it had been discovered by the original people working on it last year and assigned last year.
Yep, I was on the receiving end more than a few times of CVEs that the public didn't know about. That was under an NDA, where we weren't allowed to talk about it, but working with managed services providers, they were told about it, so they had a chance to patch the servers before the press gets a hold of it. And then, when the press gets a hold of it, all the hackers that didn't already know about it are, well, we know about it now, and we're going to use it. So it is common in this space to know about them ahead of time, which, might be jarring for some people to be like, why does it say 2020? It's not 2020 anymore. Well, it was discovered back then, but it's only disclosed now. So that's actually very common.
Yeah, and that identifier then relates to a database of vulnerabilities. Originally, it was a national database of vulnerabilities created in the US, but all other major countries actually created their own, and some corporations created their own, and now there are over 100 registries, and they are more or less in sync with each other. And sometimes some conflicts arise when assigning numbers, and it has to be worked out. But there isn't just one source of truth for that number anymore. There are lots of registries around, and interestingly enough, not all of them have exactly the same information in them. Right. Some registries are updated more often than others. CVEs, after they are announced, sometimes get revised or something like that, and then one registry might pick up the changes and another doesn't. So it's important, if you are looking for information, to look at in multiple places, because you might find something new.
And I've done that actually. I'm glad you brought that up, because one thing that I've noticed a lot is that I get a CVE number, and in regards to Linux, it could be like, Red Hat, Ubuntu, Debian. They'll have their own little script or verbiage around that CVE on their website that you can look up. So if you Google the CVE, you might find a Red Hat version of an article about it, or a Debian and Ubuntu one. And sometimes you do find more information. Even if you're not running Red Hat, it still might have some information there that you can use. Maybe they have more information than another registry. Or if you're a mixed environment and you have multiple different distributions and use, that's also useful, because you can understand, and this is especially important, which version and which package name actually fixes the vulnerability. So you could check your server to see whether or not you have that patch. And if there's no patch available, you could just keep looking at it and just see, when that's going to come down, and make sure you get that downloaded.
We kind of glossed over this, but that identifier relates to an entry, and that entry has some description or another of a new vulnerability or some exploit that has been found for any type of systems. It doesn't have to be open source, it doesn't have to be Linux, it can be closed source systems, third-party applications. There are CVEs on a lot of things. It's not just Linux related or open source related even. There are multiple CVEs for Microsoft products. Exchange a few weeks ago had a few, and people are still working on them, and that print nightmare stuff. Let's not get into that.
That'll get me heated if we talk about that one, and it's out of scope anyway. But no, you are right. So it's not LVE, Linux vulnerabilities and exposures. It's the word is common, which means these are common vulnerabilities, just like the name would imply. Of course, our scope is going to be Linux, but I think it's unavoidable to talk about other technologies on this podcast. So we'll definitely have to get into some other things here and there as the topics require.
And also, the information that you'll find on the CVE, before it's made public, the CVE will just say something like this CVE identifier has been assigned or requested or something like that. The wording varies from registry to registry. And during that time, what happens is that security people are still looking at the problem, are still trying to come up with a solution for it, warning the original vendor or whoever created the code that they have this issue, and working with them to try to solve it and create patches for it, so that when it gets publicly available, so that when you or me that have no connection to some other entities look at the information, we see the finer grain description of what actually happened. And there are some solutions available. Otherwise, we would just be giving the hackers the tools that they need to exploit the services. And so even when it's public, that description on the CVE has to tread this line of not being overly specific by pointing to actually flaws, because there are still systems out there that are unpatched, and has to provide enough information that the sysadmin can actually work on it and try to come up with solutions if it doesn't have a patch available, like closing specific network ports or closing file shares or changing permissions somewhere. And sometimes it's really hard to balance that. So
right. Yeah. And I've seen some weird situations where the workaround is just funny, or maybe just ironic, where there was this vulnerability. I think it was with Atlassian at one point with their contact administrator form. And in the workaround, it says, disable the contact administrator form. Just turn it off and you'll be fine. Oh, well, great. But what if they need to contact the administrator? What do they do? Until a proper patch comes, sometimes you just have to have workarounds like that to get through it.
Going back to Microsoft, if you recall, a few years ago, they changed the way they produce the information around their security patches. They used to have these very descriptive security bulletins where they would say, we changed this file and that file and that file, and this affects this service in this way. And at some point in time, I believe it was around Windows 8.1 or something like that, they started to have these very terse messages that just said, oh, we updated something in the kernel or something in file sharing or something in user interface, and they don't provide more details. And that's part of the reason. It's to avoid giving out too much information. You can still, but they don't hand out that freely like they used to do. And that relates to the same reason why CVEs messaging sometimes is not that obvious or clear to everybody.
Yeah, I've seen this before. There's a debate about that, right? So the more information you give out, the more that it can be used. And then as a system administrator, if you're going to be installing a patch, you also want to know what that patch contains, especially if your users are complaining that ever since you patched the server, something isn't working right. Then it's like, well, what in particular could have changed? Well, I don't know. There's nothing in there. But there's that balance. It's really hard to reach, I think, between end users and the developers.
Mm-hmm. Yeah, that's really a problem. Sysadmins like to have all that information available. They don't want to just blindly install anything that pops their way, because it's not the first time or the second or probably not the last time that when you install an update, you break something that you weren't expecting to break. And then it's more work that you need to fix, and it's more configurations that you need to work on, and it's a chore. So if you can avoid that, great. If I see an update that says it's going to change this configuration or this functionality this way, and I'm using that, I won't install that update immediately. I'll try to find some other workaround. If I don't have that information, I can't make that choice, so I'll install it blindly and then deal with the aftermath. But yeah, it's tough to balance both things on every situation.
I think that's part of the reason why a lot of enterprises out there have a testing or sandbox version of their production server, so they can apply those patches, kind of see what happens. They could have some test cases that they can go through to just see what works and what doesn't. I've seen some companies actually elect some users that are the cool users, the calm ones, to be little guinea pigs. That's not what they call them, obviously, but they roll it out in little phases. Like, these people, they want to be using the latest and greatest, so that's fine. We'll give the patch to them first, and then if they don't complain in a couple of days or a week, we'll just graduate that up a level, and then up, and then up, and then up, until it's across the whole company. And a lot of people have to do things that way.
And that's actually the proper way to establish a test environment. If you just have a copy of the production servers, but you have no one actually using them, you won't spot the problems. So you'll have the systems, the update installs correctly, but then nobody validates that. So having some users, a test group or something like that, working on those systems, that's the way to do this.
Yeah, totally agree. And it's, as an aside, it's a little out of scope, but it's just very important for many reasons, not just security, especially when you're installing an update for any reason. It's a major new version. You want to know what's going to change, how the experience is going to be impacted, and you get a chance to take a look at that. But also, you can see what the upgrade process, what it actually looks like, because it's no fun. I don't know about you, but it's just no fun when you upgrade a production server and it just borks everything and you have to rebuild it. So if you have a clone of that server and you just run through the upgrade process, hopefully you'll see that problem before it becomes an actual problem. Yeah. So if you're not setting up test servers, you probably should.
Yeah. Or a complete test environment if you should. Yep. The ideal situation would be to have a completely replicated production system in some closed test environment. Mm-hmm. Obviously, with the current outside dependencies that everybody has on identity providers or cloud providers or something like that, this gets harder and harder to replicate, but it should still be the goal to try to achieve.
Absolutely. So let's talk about resume. No, we're not going to be doing a career development section on this podcast, but I think resume padding is something that happens, and we should probably talk about that too.
Yeah, so we're having more and more CVEs popping up all the time. So the rate that they are being publicized or created or requested, all of that has been growing and growing, especially in the last couple of years. Things have been hectic on this field. A week doesn't go by that you have 5 or 6 new CVEs that you need to deal with, and it's always important stuff. It's always a mess to deal with. It will break something and you have to clean it up. And basically, this might be one of the reasons why CVE is reaching its limits. And the reason why one of the reasons why we're getting so many CVEs, first is because more people are looking, and that's always good, and more security researchers are paying attention to code, and that's always great. But then you also have what you just called correctly resume padding, and I invite whoever is interested in the topic to look up a presentation by Greg Crow-Hartman on CVEs being dead and long-lived CVEs. If you Google that, you'll find it quickly on YouTube. It's really interesting presentation. But he mentioned resume padding as one of the problems. And what is resume padding? Imagine you're trying to break into the security research field. You want to have something to show to the interviewer. So it's amazing when you get to the interview and you have founder or discovered the CVE number so-and-so on the Linux kernel. And that's great. This guy looked at the kernel, he found a problem, he found some solution, he worked this out. So he's probably a great guy and he knows security and all that. But in the end, it might be something really stupid in the code, some condition that will never happen in production in a million years, something that would never be triggered. And the new CVE was assigned, and now you get all the Linux distributions dealing with the new CVE popping up that they are mandated to include in their kernels by their own compliance teams. And now it affects the whole industry, and it was something that would never be a problem. It was something that Greg, on his presentation, he mentions something really stupid, which was, if at boot time we cannot allocate 128 bytes because we're out of memory, we should not continue. Yeah, if you can't allocate 128 bytes, you have bigger problems than that. That's not a security issue. It would crash anyway. So yeah, a CVE was created for that. And that's a condition that will never bother any other system. And that created patches on Fedora, that created patches on NetApp, on lots of distributions, which were then reverted a few time after that. And it was just a mess with something that would never be an issue. And some CVEs are like that. Yeah. People want to show themselves up. They want to promote themselves. So what better way than having their name on a new CVE? And that's resume padding. And that's an issue that the system has.
So it's kind of like a vulnerability, hypothetically, where it requires a flash drive to be inserted with a very special named file at the root of that flash drive. And it's like, okay, if the person was able to get past security to the data center and put a flash drive into the server, there's bigger problems than that vulnerability. And I would argue that's not a vulnerability. Come on, don't let people into your data center that you don't know why they're there. It's probably the bigger
A couple of years ago, there was a CVE filed against the floppy disk driver on the Linux kernel.
Oh, I was just thinking about that too. Yeah, it was especially the VMware. I think even QEMU, if I'm not mistaken.
Great, there's a vulnerability there. Now it's fixed. That's amazing. But yeah, how many people still use floppy disks in production?
Not very many. The only time I could ever think of that, I think the last time I've used one was when I was updating an old PowerEdge server that was still in production, and it needed a BIOS update, but it had to be from a floppy disk. And it's just like, really? I can't believe it. You know, I'm trying to source the USB floppy disk because drive because none of my computers have that. And I'm like, I can't believe I'm doing this right now. And then I'm just downloading this floppy drive image or floppy disk image, putting it on the disk, and then it's like, really, wow, okay.
Immediately, as I said that, who was using a floppy disk, I remember some issues Boeing had, the airplane maker, and they use floppies on some of their systems in the airplane. So yeah, they use floppies.
I don't know if I want to fly anymore. They're powered by floppies. I mean, like we're flying in a plane, and then the clip on the disk gets stuck in the reader, and they can't get the other.
And you have to put your finger there and just wag it a bit up and down so that their head can get through that sector.
Get a paper clip and kind of just pull the metal clip out of there. Oh boy, I do not miss those times at all. Fun.
Yeah.
And, I think to piggyback off of that a little bit is that we were talking off camera about the fact that some system administrators don't really have a choice, right? So they have a vulnerability that's been reported. Their organization requires them to answer the call and get that patched. But even if that vulnerability is something that, the planets have to be aligned in just the right way, and there has to be a solar flare at just the right time or whatever it is, but they have to patch it. So when you have resume padding, it kind of seems to me that's going to cause administrators a lot more work for no apparent gain. And that could probably cost organizations a lot of money in hiring more people to apply these patches, when it's probably arguable which patches were the most likely to cause an actual issue.
And it's not just the resume padding. There is some stuff with compliance there as well. Some organizations have rules that say that if a vulnerability pops up, a new CVE pops up with a score higher than, say, 5 or something like that. And yeah, CVEs have a score, and I'll just get back to that in a minute. But if a CVE pops up with a score higher than 5, you have to install it immediately. You can't wait. Nothing has to wait for that. You have to deploy that. Red Hat, for example, has a policy that says that their Red Hat Enterprise Linux has to get all the security-related CVEs. They have to get into the kernel. So if a new one pops up, it might be something stupid, but it goes in. And if it's then reverted a few days afterwards, then the revert gets in as well. But in the meantime, you already had some updates go out, and you had some customers deploy that new version and all that. So it's already a hassle. And I just briefly mentioned the scores. We haven't spoken about that yet. CVEs get assigned the score. When you request a CVE, you explain the problem, the registry will assign you a score. It's a number. It goes between 1 and 10 usually, with 10 being the most dangerous or highest risk, and 0 being less risk or no risk at all. And there is usually more than one number. One is for risk, the other is for impact. So impact is the number of systems that can be directly affected by it, or type of distribution, or number of distributions and all that. And the other one reflects the actual danger, whether it's data exfiltration or it's denial of service or something like that. So yeah, the CVEs get assigned that number. It's highly debatable how the number is assigned. It's very subjective. Some registries will assign them one number, others will assign it another, and it's not always easy to understand why that happens. But that will affect the companies that have specific policies around that severity score, and will make those organizations deploy their patches, even if it's not something that would directly impact them.
Yeah, so it's really important to take a look at those factors when you're, assuming you have a choice. You're not just patching all the things as soon as the patch comes in, but some of these are more likely to cause a problem for you, and some are not as likely. And I don't know about you, but remote code execution, oh gosh, as soon as I hear that, that's a big deal. That's among the most scary types of vulnerabilities out there. That it just executing code remotely. That's what a hacker really wants to be able to do, and that's like direct line of access there for them to do that. So that's always a bad thing too.
Getting a remote shell with root privileges without anything else, that's game over.
Yeah, another thing too is vulnerability chaining. So there could always be like a vulnerability that requires you to already be on the system, which you could argue, well, yeah, they have to already be on the system. But if there's a vulnerability in addition that they could chain to get into the system, then that one vulnerability that wasn't remotely executable now is, when combined with another vulnerability. So vulnerability chaining, I think, is something that a lot of people don't really take into account, that it might seem like it's not a big deal, but it could be and I think that's what a lot of hackers do, if not most. They try to chain things together to get the desired output. So that root shell is the desired goal. So to get there might be a few vulnerabilities from the start to actually getting into the system. So that following through and trying to think like that is going to help you understand exactly how they do what they do.
Yeah, and that's one of the things that we see at TechScare a lot. Sometimes it takes a very long time for an organization to patch against a known vulnerability, either because they weren't aware that it actually affected them, or because they just didn't have the maintenance window open to do that. But it takes a long time. And then another one pops in that, piggybacking on the first one, will lead to greater risk and to greater damage. So yeah, if you suspect that you are going to be affected by a specific one, this is sometimes tricky to actually detect. So, for example, I don't know, OpenSSL or libcurl or something like that. Many applications use that behind the scenes. Your web browser right now, it uses libcurl. It pops up, and in the background, it calls its functions, and it will depend on libcurl to get resources across the internet. And if a new vulnerability pops up against libcurl, probably your Chrome or your Firefox or whatever vendor, they will not tell you they have a vulnerability, even if they use libcurl. So you will get a new update to Firefox or to Chrome or something like that, and you will never know that you were vulnerable to libcurl during that whole time. You just got a new update for your browser. But in the meantime, it was there, and if some other vulnerability let somebody into the system without privileges, they might have used that libcurl presence there to escalate. So it's not always that easy to understand when you're actually vulnerable to one or not. So our best advice is just to patch everything and patch all the time, and don't take unnecessary risks there.
And that's the part that I feel a lot of organizations out there have the biggest problem with, because when they hear patch, they hear reboot. When they hear reboot, they think, oh no, like my customers are going to be disconnected. And in a perfect world, they would have had, a load balancer and multiple different servers, so they could kind of roll the update one at a time and the users would never know the difference. But it's just strange how rare that is, right? Like how many companies don't do that? Maybe they have good backups, they could get up and running quickly, but they have one server. If that one server goes down, they can't reboot it. So I would talk to clients and tell them, you really do need to patch this. It's very important because I checked your system, you are impacted by this, and it's only a matter of time. And maybe we could do it next month. Or maybe the month after that. I think the new release of our product will be out, and we should slow down in a couple of months. I'm thinking, what? Like, I just told you it's critical. And then what's funny is they'll get, owned by one of these, and then, why wasn't something done? We tried. We told you like 5 times you need to get this patched right now. It just seems like there's this battle between system administrators, security professionals, and their own CEOs, and trying to get the budget or the approval to get this done. And I'm here to tell you, don't wait. You will regret it. If you don't regret it this time, it's going to bite you. I promise you, it's going to be a bad day. And if you don't want to pull like 12-hour shifts for like weeks to repair the damage, definitely patch your servers.
Yeah. And not just against the high-profile vulnerabilities that get those fancy names that we mentioned before. It's not just Spectre and Meltdown and Sequoia now. Those ones will get the limelight. Those ones will get the news headlines. But for each one of those, there are 100 that pop up that will never get assigned a fancy name, will never have a cool logo, will never have a website of their own, and they will affect your systems just as much. Yep. If you're really interested into security and into best practices in security, you need to keep your eye out for all the other ones, not just this. These ones will get the news, but the other ones will get your servers.
Yeah. Do you think there's ever going to, and I think I know what you're going to say, but do you think there's ever a time where, a hacker is looking for that in the news? They're waiting for that vulnerability with that awesome logo and hilarious name to where everyone's going to be stuck talking about this. It's all over the blogs and the news. And while everybody's busy handling that, they're going to use their secret, hack or whatever they have, and they're just going to go to town because everyone's looking at the wrong thing. How much of a problem do you think that might be?
Well, that's a very big problem, especially because most hacks and most attacks, they don't rely on the new zero-day exploit that was just announced. They will exploit something that has been laying there on that server that they've been monitoring for months now or years now. So it's not just the most recent one that gets exploited. They'll know if you updated or not because that signature will change, and they will try to hack you if you still have servers with and patch vulnerabilities lying around. Those are the ones they go after. And the new ones, they are dangerous because they get the limelight and because people will not immediately patch them, but it's the other ones that are in most servers, and that they will be the entryway for your systems.
It just seems like the clever names, while they're fun, to be completely honest, are just causing more harm than good, and just making people focus on those. And like you were saying, I think the other vulnerability is just don't get enough attention. The media loves this because anything with the buzzword on it, I mean, man, that's clickbait right there. Heartbleed will own all your servers. Oh my God, patch now. Rowhammer and all these other ones. It's like, oh boy. It seems like that might have slowed down a little bit, but now that I've said that, I'm sure it's only a matter of time before we're on this podcast and we have to be talking about one of these crazy named vulnerabilities. I'm sure
Sequoia popped out less than 2 weeks ago. And that was another ridiculous one. I know how they analyze the code. These are code tools that they just look for variables that are assigned to one type and then convert it to another with lower precision. Anyway, the vulnerability itself, to be exploited, it requires a pass whose total length has to be over 1 gigabyte. The number of characters in the pass has to be more than 1 gigabyte. And if you get that, and and you mount that directory somehow, you will manage to write a specific value in memory at a specific position that you'll know beforehand. So you have to have some other code waiting for that change already loaded in memory, and then when the stars align and you get all that in place, then you'll have some way to assess higher privileges on the system.
Wow.
And they got that fancy name. It's Sequoia because it's very big, like the tree and all that. But yeah, in practice, it's not that easy to exploit. But that got the limelight. And behind that, several other Apache ones just went unnoticed, and those were probably more widespread.
Wow,
and
that
easier
is
to
just
exploit.
so crazy.
And this was discovered by looking at the code and some variables changing types there. The thing there is that pass will be stored in a structure inside the 64-bit integer. And then at some point during some other call and some other part of the kernel, it gets converted into a lower precision value, so just 32 bytes. So you'll lose some, and there will be some overflow, and then that will cause some issues elsewhere. And this is a long chain of events. And you have to rely on some other functionality in the kernel, the Berkeley packet filter, the BPF, that lets regular users load code directly into the kernel and run that code with kernel privileges. So basically, when you try to load some BPF code, and BPF code here can be used to directly affect network packets or do some other type of operations. That's unimportant for now. When you load whatever code through BPF, the kernel will perform some security checks. They won't let you, for instance, access things that you weren't supposed to access, but they only look at the code during load time. So you load your code, and then when that change happens because of that long pass, it will change the code that you load before and convert it into something else that's no longer safe. And through that, you can actually exploit the system. So lots of things have to happen here. But yeah, it got all the publicity, it got all the limelight, it got the news, but several others didn't, and they were just as important or even more.
Yeah, and getting back to the main point, I mean, sometimes we have a really crazy name and it just steals everyone's attention, and that can work against the security industry. It's just these people working on the front lines, they really have their work cut out for them, for sure.
They do. And again, going back to what I said previously, CVEs, they're cropping up more and more. It's getting harder and harder to track all of them, to track even the ones that directly affect the systems you're in. For example, only the CVEs that affect the Linux kernel or the Linux distribution that you're using. Every day, it's more and more CVEs that pop up. We're reaching a point where it's humanly impossible to keep track of that manually. That happened some time ago. But even through tooling and through reporting every day of the new stuff that affects your servers, it's really tough to keep track of all that. So my word of advice regarding that is, if you still haven't automated that, you really should look into automating the CV analysis and the vulnerability checks, because you won't be able to keep all that on your hands and hold that on your head every day. That's really, really tricky to do.
And don't just assume an apt dist upgrade is going to protect you from everything just because you have all the patches and things. You know, there might be some additional things there that you have to keep in mind. There's other security measures, which we'll especially cover in this podcast as we go, because there's all kinds of best practices. I mean, we're talking about CVEs right now. That doesn't even get us started on open SSH best practices and what ports should you open up to the public, which I answer none, but that's another story. I mean, obviously you have to sometimes, but there's all these different things that are accounting, or you should take into an account, and CVEs are the most important thing, in my opinion, because that'll get you an understanding of what's out there, what's happening, what are the hackers actually going after right now, keeping your eye on that, and following some blogs and setting up an RSS feeder with a lot of these blogs that cover these things as they come out. That's also a very good thing to do as well, because there's a number of those blogs out there that you should probably follow that would help you, you know, maybe not your only source, but definitely can get you a heads up if there's something coming out.
And will make you look at things in a different view. Sometimes people just focus on what they want to see and what they are used to doing, and they have to look outside the box and think outside the box in these kinds of situations. For example, when you mentioned that apt update, something that really bites new sysadmins when they perform an update on a library, on a shared library like OpenSSL, just to cover a vulnerability that popped up. You should know that you're just updating it on disk. You're not restarting the services. The services that are running that depend on OpenSSL, they are still using the old code. Until you restart them, you won't pick up the changes. Even if app tells you there are no more updates, you're still not protected.
I think it's really amazing. It was amazing to me when I first started. And disclaimer, absolutely nobody should do what I'm about to mention, ever. But as a new Linux person, of course, I have this server that I found. I was just playing around with it. Wasn't production, wasn't important. And I loaded Linux on there. I had a web browser open. I was browsing some web pages, and I just disconnected the hard drive SATA cable. I just pulled it. And it was amazing to me how much of the distribution still worked after pulling that SATA cable. Obviously, a lot of things were broken, but my web page was still there. My apps were still open because they were on disk. They're loaded into RAM and they're running from RAM. Obviously, if I close an app and go to reopen it, it crashes. And really, really, really bad things will happen when you do this. It'll absolutely break things. But it was just the way that I understood it, or actually, it's what made me understand just how important it is to keep in mind what's running in RAM, because Linux is very, very focused on that. Like Windows, from what I understand, would probably blue screen instantaneously when you pull that SATA cable, but a Linux system is going to keep on going for a little while longer. And obviously, that's not something anyone should do, but it does kind of frame the thought that when things are running in memory, they're running in memory. You update it on disk. The next time you open that app, sure, maybe it'll be in memory then, but you have to close the app or reopen it, reboot the server. Better yet, just use something that gives you a reboot-free update experience, which TuxCare will definitely help you out with. And I absolutely want to mention that because you really should be taking this into consideration, that just updating it by itself, that's not enough. Either you need to reboot or you need some kind of live patch service that'll inject those newly updated libraries into memory.
Yeah, absolutely. That's basically what we do. We facilitate that operation. But again, I really don't want to be pushy on this. This is not the goal of the podcast. We mentioned this because it's topically related. Getting back on track, this is a very, very tough problem to manage properly. If you find security interesting and if you want to learn more about CVEs and all that, there's a wealth of information out there. You should really look into some of the things that Greg Crow-Hartman has to say about it. He's one of the top people on the Linux kernel. He has some very strong opinions about this and other things, but yeah, he's very respected in the medium, and I really look up to him on these matters. And CVEs are probably reaching the limits of their usefulness because there are just so many of them. We should really try to find, it's getting overwhelming. We should really, as an industry, try to find some other way of tracking vulnerabilities. But again, this is the current de facto standard, and it's not going away today or tomorrow, this year or the next. So we'll have to deal with them in the future. But probably something new will come along at some point.
Well, I'm sure they will. I think for an administrator, it's just really important to understand your organization's policy about patching, number one, but just also taking into consideration, too, if you kind of feel like there's some weak areas in this policy, maybe some things could be improved upon. Let your management know about that if there's something you think isn't really getting a good service in that policy. Or it is especially bad if you have no policy at the company at all. That's an even worse problem. But there has to be an order of operations here. Looking at the vulnerability, assessing the vulnerability, figuring out what the scope of it is, what's required to update, how important is it actually, how likely is it to impact your organization negatively. You have to understand those things and be able to pay attention to those things, because you don't really want to get that call that you've been hacked and it's something that you feel like you should have probably paid attention to or would have been on your radar if you were reading the appropriate blogs. Another thing, too, is there's going to be some blogs out there that are very clickbait heavy. I don't really feel like those are a good source for information, because some of them might give you some information, but those blogs, in my opinion, are probably only going to show something if it's really newsworthy. Meanwhile, you have a bunch more CVEs out there. So definitely pay attention to those. follow the blogs. Don't use that as your only source, but at least do your best to pay attention to that. Be a part of the community, not just a watcher, and engage in community discussions about security. You'll learn more. And absolutely, and I know this is probably outside the scope, but I always like to make sure people know, don't just try to do a penetration test at your company without your management knowing about it. I understand you might want to pad your resume. I discovered 15 vulnerabilities at my company, but you don't really want to be walked out the door if they discover, like you're trying to hack the company or anything. So use common sense and definitely research and take CVEs seriously.
Yeah, absolutely. That's great advice, Jay.
Is there anything else that we missed? I think that was a lot of information, a lot of great information about CVEs that'll certainly help people.
There's tons of other things you can mention about CVEs. One that we didn't mention, I talked about this national vulnerability database. Mm-hmm. The national part there is very interesting because it's just the US. The other countries, they obviously have their own internal policies about disclosing vulnerabilities, and it's probably unlawful on those countries to send that information to the US. So other registries will have other information. China has registries, Germany has registries, France has registries. It's not just the US. The numbers should be unique across them because there is some communication between them, but there may be more information on others than just the national ones for the US.
That's definitely good to know. Good to know. All right. So, wow, that was a lot of information, but I really like the way that was laid out, because I feel like if I didn't already know about CVEs, I definitely would know the required things. I think that puts our, gives our audience a great foundation to explore CVEs, understand what they are, why they're important. And as a foundational topic, I think that was indeed a great fit for episode number 1. So, let us know what you guys think when you listen to this. If there's anything, have any questions, comments, future topic ideas, definitely leave them in the comments. We would love to read those and, know what you guys think and what you guys want to see, or in this case, hear.
Thanks, everybody.
Yeah, thank you guys for listening. We really appreciate it. Like I said before, we're going to have a more exact time in the future as we kind of get into the status quo. But so far, so good. Thank you guys for listening. Stay tuned for the next episode, which we will have out in about 2 weeks from now. And we'll see you then.
Bye.